This is number 2, 2014. Hopefully when you see a problem like this and you go, okay, this is an area volume kind of problem, this is 7, 8, or 9 points. I hope that's what you're thinking. And I'm always surprised by the averages for these problems are so low. Let R be the region enclosed by the graph of x to the fourth minus 2.3x cubed plus 4 in the horizontal line y equals 4. So this is y equals 4, and I'm probably still in the wrong color. Let me get this back to a little bit bigger here. Okay, so this is, oops, y equals 4. And we want to revolve it around the horizontal line y equals negative 2. So we're down here at negative 2. Okay, so I'm going to take this guy and I'm going to revolve it around and do this sort of thing. And I have to recognize that I've got a washer here. So A. And let's do a different color. So for my washer, I know that my piece of washer is going to be pi times capital R squared minus little r squared. And then my thickness is delta x times delta x over here. So what's capital R? Well, I start at the center, and my capital R is always my distance, my big radius, all the way up to the function that I know. So that distance is 4. So it'll be pi times 4 squared minus, and then little r, do that in green, it's going to be, I see I messed up already. Let's go back. You already caught me on that, I bet. This distance, it's 4 minus, how big is this? See, I just assumed it was 0 because I wasn't thinking. So it's 4 minus negative 2. It's a big number minus a little number. So it'll be 4 minus negative 2 squared minus, and then little r is this distance here. Well, the big number is this function, which is f of x minus the small number, negative 2 squared dx. Okay. So then I've got the actual integral is the volume, it's pi, times the integral of, this is 4 minus negative 2 is 6 squared minus f of x plus 2 squared dx, and this washer starts over here at 0 and goes all the way over to the end here, which, I don't know how far that is. I have to figure out how far is that. Where does the graph of f of x and 4, where do they intersect? How do you figure that out? Well, where is f of x equal to x to the fourth minus 2.3x cubed plus 4 equal 4? Okay, well that's x to the fourth minus 2.3x cubed equals 0. Well, that's when x cubed times x minus 2.3 equals 0. That's when x equals 0 or 2.3. So this is 2.3. Now you could just solve that on your calculator, and graphed this and just said, hey, where is it equal to 0, and got the same answer. So this is from 0 to 2.3. Now, if you do, here's the expression, and I put this in my calculator. Of course, I got to fill in f of x for the actual function, and if you do that, you get 98.868. And of course, you get this whole part is worth 4 points. It's 2 points for the integrand, so you get 2 points for this guy. you get 1 point for the limits and 1 point for the answer. Okay? B. Okay, erase this. Okay, actually I guess I'll resolve this since I don't need this down anymore. We know this is 2.3. Okay, region R is a base solid. For each solid, the cross-section perpendicular to the x-axis is an isosceles right triangle with a leg in R. So perpendicular to the x-axis, so it comes down like this, and then coming out of the screen is a right triangle where that is congruent to that. Okay, and so this one over here comes out of the screen, isosceles right, that's congruent to that. This guy over here, isosceles right triangle. Okay, you get the picture. Okay, for each solid, find the volume of the solid. So let's look at one of those triangles. Just the one triangle. Well, what's the area of a triangle? Actually, I'll go volume here. Is the area of the triangle times the thickness, delta x. Right? Well, a triangle is 1/2 the base times the height, and the volume is times the thickness. So it's 1/2 the base. How long is that guy right there? Well, it's 4 the top minus the bottom. 4 minus f of x. And because it's isosceles, the height is the same height. The same length, sorry, squared times delta x. So then the volume is the integral from 0 to 2.3, because I have to add them up, of 1/2 4 minus f of x squared dx. And then you can plug in f of x into here, and you would get, we're going to just go this way, 0 to 2.3, excuse me, of 1/2 4 minus x to the 4th minus 2.3 x cubed plus 4 squared dx. And so what you'll actually be putting in your calculator is 1/2. That 4 and that 4 cancel, so it would be negative x to the 4th. Did I really just do that? Forget to put those parentheses in? I did. So it would be negative x to the 4th and then plus 2.3 x cubed dx. Sorry, it's late and I wanted to get these to you a few days ago and I just haven't had a chance to, so hope I don't make too many of those. Anyway, so you do that on your calculator, and if you do, you will get 3.574. C. And that is worth 3 points. I'm sorry, 2 points. You get 2 for the integrand, and 1, that's, 3 points. 2 for the integrand, 1 for the answer. C. The vertical line, x equals k. So let's erase this again. Divides this area into this region into 2 equal areas. Write but do not solve an equation involving integral expressions whose solution gives the value of k. So there's some point here, vertical line x equals k. So this is k, so that this area on this side equals this area on this side. So I have to write an expression for that. Well, that just means the area on the left here is top function minus the bottom function from 0 to k dx must equal the area on the right, k to 2.3 4 minus f of x dx. Okay. And that is the equation. It seems like it should be harder for number 3 or part C on this, but that's not. So there you go. Alright, and that's worth 2 points. 1 for writing the area of the region and 1 for writing the equation. So there you have it.